For today's laid-back tutorial, I have a very nice, clearly Canadian blackberry flavored soda. Hello everyone, Lumpology here, and today in this tutorial we're going to be learning how to install libraries in C++. Libraries provide more functionality to your program. So to demonstrate library functionality, I'm going to install two libraries into C++, both of which give different graphics capabilities to your programs. The one we'll be using in this tutorial series mainly is going to be FreeGLUT. However, I will also be installing SFML for redundancy's sake. SFML installation and usability was asked for at the request of one Ryder Hogg, who was unable to get SFML working. So let's start. Alright, for starters we're going to go open a new tab and we're just going to search SFML. And we're going to go to the SFML website and we're going to go to download, latest version, and we're going to look for the nice one that says mingw, except we don't want this side because this one is DW2 32-bit. We installed the nice 64-bit SEH version of mingw. So we're going to download that instead. Hit OK, and it will take a second for the files to download. Okay, so I'm just going to move the SFML zip file that we just downloaded into our project folder. And in this folder, we're just going to explore the zip file. So this zip file, we're going to note, has a few things that are important. It has the lib file, the include file, and the binary file. Inside of the binary file, we're going to find the DLLs that are important to run SFML. Inside the include files, we're going to find the SFML folder containing the C++ headers and code that runs the library. And in lib, we'll find the integration packages that are marked .a. So, things to remember: the license must be considered when you package your software with a library. I always recommend researching what the license is for any given software. If I open this license, it tells us that SFML is software provided as is without any express or implied warranty. So this is basically a zlib license. However, it also mentions that these resources it uses, OpenAL, SDBimage, FreeType, libogg, libvorbis, and libflac are all under different licenses. So you can search the BSD license, the GPL license, and the FreeType license, as well as this one is under public domain, and this one is under LGPL license. So just keep that in mind. SFML appears to be under zlib, so just keep that in mind. Next thing to remember is if we actually go to the SFML website where it shows you how to install it from mingw, it's showing you the code blocks way, which code blocks is an IDE you can use, integrated development environment, that comes with a compiler, mingw. So we can actually use the installing guide for code blocks just with mingw. So things to go to: if we go to our root drive on our computer and find where we installed mingw, we'll find this folder, and then we'll go to mingw64, and then you'll find this. So you'll notice there's some matching files in this folder, but you need to not get confused by this. In SFML, in the SFML drive, we have bin, include, lib, and you'll also find bin, include, and lib. These are not the files you want to be putting stuff into. there's another folder down here called x86_64-w64-mingw32. That's actually the location we want. This stuff has to do with mingw. This is C++. So, the bin is not important to us. I'll show you why in just a second. Bin is only important in a different pretext. So, what are we going to do with bin? We're going to go inside of bin. We're going to take these DLLs. We're going to copy them, and we're going to put them in the same folder as output.exe, which is our program output. So it's just going to extract these from the zip and put them in the path here. These DLLs are going to be packaged in your final software with output.exe. So keep that in mind. Next, inside of SFML, we're going to go to the include folder, and where it says this SFML file, we're going to copy that, and we're going to put it inside the mingw include folder right here. So this is, we can find all our headers in here. There's bits. So these will be recognizable if you've been programming in C++ for a while. You'll know what most of these headers do, but that's not what's important. Inside of this folder, we're going to right-click and we're going to paste SFML into here. So now we have SFML right here with its headers inside. Okay, now we're going to go to lib right here. We're going to open this, and we're going to go inside the mingw folder, and we're going to go to lib. So inside lib, you can see all of the .a files, and what we're going to do with the sfml.a files is we're just going to take them like this and copy them over here. As you can see, they're all here, lib with the name lib sfml. If you want to uninstall them, just search their names up here, one at a time, go through the list, and remove them. The CMake file is not important for this. It's only important if you're going to use CMake to build your projects. Okay, so now we have those three in place, but we're not quite done. So if we go back to the SFML website, you'll notice this here, SFML-graphics, SFML-windows, SFML-system. If we look here, you'll see all of these commands that go alongside it. These are basically dependencies, and there's this nice bit of sample code that we will use along with it here. So if you remember, if we return to our project folder in compile.powershell1, we have this line right here, and in it are these little -o and -std equals C++17. These are our compiler commands and are how we link stuff to mingw, how we decide what we're compiling. This one tells us we're compiling with C++17. This one tells us where we're compiling to. It's just little commands we're going to input into the line. All right, so we're going to go to the website with SFML on it, and we're going to copy this little hello world script into our project's main.cpp. Okay, so here's the code we were working on before. this is the code we have now. So we're just going to save that, and this is the code we're going to type in, but don't compile yet. So back in our compiler script, we're going to input a few things. Okay, so right now all you're going to need to do is after G++ and after it says main.cpp, just put a space, dash, and we're going to say L SFML dash graphics space dash L SFML dash window space dash L SFML dash system. So these are the three linker commands that will hook up basic SFML for what you need. You can look back at the API and the documentation reference if you need more options. So with these in place, save the file and run the PowerShell script. Compiling finishes. Now, if you double click on output.exe, SFML works. There's the window. Alright, now for redundancy's sake, we're going to do the same thing again, but this time we're going to use FreeGLUT. So FreeGLUT is basically a remake of the original OpenGL Glut library, which is almost as old as the Open Graphics library is itself. So FreeGLUT is a remake of it, and it's open source and it is great. So with that in mind, let me get us a tab. So we're going to look at FreeGLUT, like so. We're going to go to this SourceForge page right here, and we're going to scroll down to where it says prepackaged releases. We're going to get Martin Payne's Windows binaries, Microsoft Visual Studio, and mingw. So in here, we're going to want to go to the FreeGLUT 3.0 package mingw. And just take where it says FreeGLUT 3.0.0 mingw. This is the one we want. We can say it's compatible with Dev C++ and code blocks if you're interested in that in Eclipse. So click on this, get this folder here, save file, okay. So it basically insta-downloaded, and so we're just going to go to the downloads and find our new FreeGLUT folder 3.0, 3.0, 3.0. There it is. Alright, so this is the file. You can just cut it, and we're going to put it inside our project folder right here. So inside this project folder, here's our file. Let's inspect it, make sure everything's here. We've got bin, include, lib. So much simpler to install FreeGLUT than SFML, because bin only has a few things in it. So we're going to go to x64, we're going to grab the FreeGLUT DLL, copy that into the root with the exe. We're going to go to lib 64. We're going to take these two A files and we're going to put them in our mingw this lib folder. Then we're going to go back to project and we're going to go to FreeGLUT and we're just going to grab the include folder and we're just going to go inside GL and take these two folders. mingw by default comes with its own GL folder, so that's just makes our life a little bit easier. GL is kind of like the universally accepted way to reference GL files. So there it is. There's our include folders. So now if we hop back to project and open main.cpp, open it with Atom. Okay, so now that we've got it open with Atom, we're just going to replace it with a new script. Alright, and because they don't provide a readily available Hello World script, we're just going to make our own. So in this case, we're just going to say sharp include, and then we're going to say GL, and then we're going to put a slash, and we're going to say glut.h. It's a folder, and then we're just going to set up a display void display, and that will do that. So inside of, we actually won't get that yet, we'll just set up int main, and then we can just roll pass some stuff. Yeah, we'll set up the arguments. Just, you don't actually really need to know what these are, but we're still going to use it. So arg C char arg v. So yeah. So inside of here, we're going to work with some glut functions. So glut init, or initialization, and we're just going to put this and symbol, and we're going to say arg c arg v. I'll explain what arg c and arg v are in a later video. They're very important, though. Not per se to this, but they're very important in general. So glut init display mode, and we're just going to set up, we're just going to pass an enum in, and it's going to be a glut underscore single. And then we're going to say glut init window size, and we'll just pass in something like 800, which I believe is the standard for like Khan Academy. Then glut init window position. That's spelled right. And then we're just going to say 200, 200, something like that. All right. Then we're going to say glut create, and then window, and inside of here, we're just going to say glut works, keeping continuity with our SFML work. So in here, glut works, pass a string. Glut display function, just func, and then we'll type in display. So maybe display. So we passed the enum display in there, and we're just going to say glut main loop. We will set up a proper glut tutorial very soon. It's just, oh, and close it off with return 0. Okay, so this is just the initialization of the glut package. And this just basically sets up what our functionality is. We'll be using this a lot in glut programming. However, I don't think I'll be doing glut programming this season. Probably I'll wait until the second or third round of videos before I start doing glut programming, just so that we can properly learn C++ before. But other than that, it's fine. I've seen people also in these brackets here put the word void on their display buffer. I don't think that's actually a necessary thing. I think that's just old habits for some programmers. I don't really know its purpose. It may have been important at one time, but it's really not anymore. But anyways, after this, GL clear. So we're just going to have the reset here. So GL underscore color, oops, sorry, I can't use the U, underscore buffer, sorry Canadians, bit. And then this is just going to, as the display function, or sorry, void loops, it's just going to clear the color from the buffer. So GL begin, because every frame needs to reset the state. So GL underscore poly, GL polygon, enum in there, and that's going to start the drawing of the polygon. So in here we're just going to say GL vertex 3 float. Alternative, we can have I for integer, but we're going to use a float, and we're going to pass in 3 floats because we're working in 3D space for this case. And I think yeah, we're going to use 0.0 and then 0.0, 0.0. We're going to need to pass 4 of these in for this polygon. GL vertex 3F. Might actually put this into buffer, my clipboard for now. And in the next one, we're going to say 0.1, 0.0, 0.0, like so. It's kind of proper form to put spaces in. You don't really need to, though. And then the next one, we're going to say, I'm going to bring my numbers here, 0.1, 0.1. Eventually you'll get this stuff memorized. It really helps in the long run. 0.0, 0.1, and yeah, it's 0.0 next. Gotta check my notes. Next, then we'll say GL end, and followed by GL flush. Get rid of our buffers, and I might actually just add for the vertexes, I would actually give it a color. So GL color 3F. It's trying to autofill. That's very, oops, why is it doing 2 places at once? That's wild. What is that? Okay. I didn't even know it could do that. That's very neat. GL color 3F, and we're going to put in here, we're just going to say, I believe it's RGB, so if I want to make it red, I'll say 1.0, 0.0, 0.0. Yeah, so there's a color for you. That'll color your cube. Nice, pretty color. So next we're going to compile this code here. So in project, we're going to go to compile .ps1. We're going to edit it. It'll open PowerShell ISE, and just get rid of our SFML compiler code. And after here, we're just going to have to put -l glut. All we need to do. Voila, complete. So next, click C++ project, and I believe all we have to do now is compile. Hope for the best, and it failed. Okay, the reason I got it wrong was old habits die hard. I did put it in the wrong compiler command. So -l FreeGLUT, just note you can't forget the L. L actually means linker. Funny fact, fun fact. -l open GL32. So this is just for the system. That's this for FreeGLUT. No, don't put -l glut. It's -l FreeGLUT. Okay, so with that done, yeah, I think I modified this slightly. Doesn't really need to be there. Anyways, I was hunting about for a bit. There we go. You compiled. Woo. So With that done, just open this. GL works! Yay! And it's got a red cube in it. Oh my god, it's so cool. OpenGL and Glut is a way more powerful system than SFML ever will be, and that's why we'll be using it in this tutorial. It can do 2D stuff too. We're just not doing that right now. So yeah, now you know. Yay. Windows 10 H is not necessary. I just was testing something earlier. This is what happens when an hour happens between your last cut video. See? It works just fine. Okay. Anyways, thanks so much for watching. I'm Coach, and in the next video we're going to be getting back in track into some proper C++. What do I have planned? Well, I will tell you my notes here. We are going to be doing math types, so that will be fun. So yeah, learning all that fancy math stuff in C++. So, without further ado, that concludes. If you like this, please leave a like and subscribe. If you did not like this, dislike it. And don't bother subscribing, because actually you should. And yeah, so thanks so much for watching. Goodbye. Oh, curiosity is getting the better of me. I must know. Can I just do this? Nope. Okay, so keep that in mind. I'll see you in the next one. Bye. Oh, wait a minute. Sorry, I made this more confusing than people would have liked. You don't need a Windows thing, Windows header. Oh my god. Ah.